All right. What are the three other synonyms for solutions that we talked about earlier this week? Give me one word that means the same thing as solutions. What'd you say?
Zero.
Zeros, yes. Zeros. What else? Yes, ma'am. Roots. And then we've got one more. X-intercepts. This question will pop up again and again and again. I've asked this as a test question before too. Give me all these synonyms, because it's really important that we know when you're reading through the directions on a problem, what does she want me to do here? And if I say find the roots, and the very next question says solve, you're going to do the exact same process on these two problems, because that's the same question. Solve is the exact same thing as find the roots, or find the x-intercepts, or what are the zeros. All right, number 2. We want to find the distance. What do you know about distance? Distance is always positive. Only positive numbers. What is the distance between each point and 0 on the number line? So I'm going to come and look at that first point, point A, that's right here. What is the distance between point A and 0 on the number line? 3. This is the exact same question as what is the absolute value of -3? What about point B? Here's point B. What is the distance from point B to 0 on the number line? 5. Anytime we're talking about distance away from 0, we're talking about absolute value. What about for point C on the number line? 3 units away from 0. The absolute value of 3 is 3. Shh. Unless you are talking about the bell work, please stop. D is right here. How far is that away from 0? 1.5, 1.5. Absolute value of 1.5 is 1.5. What about point E? 2.5. It's over here on the negative side, but again, distance is never a negative number. So 2.5 units away from 0. And last but not least, point F, which is right here. 0.81. Please don't forget, today is Friday, so what are you turning in to me before you leave the room? Bell work. You will, it does not matter who said it first, it's not a contest. Please don't forget to turn that in before you leave the room, so when we get to the end of our lesson, when we hit that D-lunch study time, I'd recommend you put it in the basket at that point so it doesn't get forgotten, because I will put those in over the weekend. We're going to start off on page 93. Getting dangerously close to page 100.
Wow.
Page 93. Our focus for today is going to be converting between different forms of linear equations. We've got 3 different ways that we can write linear equations. We're going to focus on just 2 of those today. Standard form is this form right here. AX plus BY equals C. Our first problem, we're going to practice going from slope-intercept form, from y equals form, into our standard form. There's a couple things that I want you guys to notice about this. A, B, and C, it says they are integers. These are all whole numbers. Bless you. A, B, and C cannot be fractions in standard form, so we'll have to figure out how to get rid of any fractions that we might have. The other thing that has to be true when we are in standard form is that that first value, that first coefficient, A, isn't just a whole number, but it has to be positive also. So A, B, and C all have to be whole numbers, and A also has to be a positive number. All right, let's go and look at the equation that they gave us. What form is this in right now? What I circled in green. What form is that in? Y equals mx plus b. What do we call that form? You're absolutely right. What is the name of that form? What does m tell you? The slope. What does b tell you? The y-intercept. So this is called slope-intercept form because those are the two key pieces of information that we can find from it. This is slope-intercept form. We're going to take it from slope-intercept form and we're going to convert it into standard form. So that means I really have to pay attention to what standard form looks like. Where are x and y in standard form? Are they on opposite sides or the same side?
Same side.
Same side. So if I'm going to put this into standard form, I need x and y on the same side. Are they currently on the same side now? Are x and y on the same side? No. I need to get them there. I'm going to leave y over here. I'm going to get x to the other side so that I have x and y together. Because after the equal sign, I want just a number, nothing that has variables. So I'm going to leave the 14 there. Is that 2/5 x a positive or a negative number? Positive. So how can I get it to the other side? We're going to subtract it. I'm going to subtract 2/5 x from both sides. Is the y that was already over there a positive or a negative number? The y is a positive. I'm going to pop a little plus sign in front of him to remind me of that. So I have negative 2/5 x plus y equals 14. Do I have x and y on the same side? X and y are on the same side. So is this in standard form? Why not? I agree. It's breaking two of the rules. There's three things that have to be true. X and y have to be on the same side. What else has to be true? The leading coefficient, the very first number, has to be a positive. Is ours a positive? No. What do I have in the front? I have a negative 2/5. So that's one of the things that's broken right now. What else has to be true about these numbers in order for it to be standard form? Has to be whole numbers. Are all of these whole numbers? No. Where's the one that's not a whole number? Negative 2/5. If I have a fraction, what operation has happened? Division. I want to undo that division so that I can get a whole number out of this. What's on the bottom of that fraction? 5. I'm going to multiply everybody by 5, but that won't make the top a positive. So I'm going to multiply everybody by negative 5, because if I do a negative times a negative, I'll get a positive. So I'm going to multiply this by -5. If I do it to one piece in my equation, I have to do it to every piece of this equation. So I'm going to multiply y by -5, and I'm going to multiply 14 by -5. Right here, just the x part. Negative times negative gives me what? Positive. If I multiply by 5 and there's a 5 on the bottom of my fraction, what happens? If I multiply by 5 and there's a 5 on the bottom of the fraction, what's 5 divided by 5? 1. It's going to cancel out and give me a positive 1 right there. Except I had something in my numerator already. What was in my numerator? A 2. That 2 is still going to be there. That didn't cancel with anything. So I have 2x. What's -5 times y? -5y, or -5y, equals, what's -5 times 14? What is -5 times 14?
Negative, positive 9.
No, we're multiplying. We're multiplying. It is -70. Is this in standard form? Yes. What are the 3 criteria to be in standard form? Everything has to be whole numbers. We met that. What else? X and Y have to be on the same side. We've met that criteria. There's one more thing. What else has to be true? Only whole numbers, X and Y on the same side. What's the last piece?
Must be positive.
What must be positive? The very first number, the one that's with X, has to be a positive. Did we meet that criteria? Yes. Then this is standard form. What is our value for A? AX plus BY equals C. 2 is our value for A. So what's my value for B then? -5 is my value for B. What is our value for C? -70. All right. So that's how we go from slope-intercept form into standard form. Let's go the other way. Slope-intercept form. I'm still on page 93. I'm just a little bit further down the page. Y equals mx plus b. What did you guys tell me just a moment ago? What's the information that I get from m? The slope. M is the slope. It tells me rise over run. What information do I get from B? This is which piece? M is the slope. B is the y-intercept. On my graph, the y-intercept is where it touches the y-axis, so there's M. How much I go up by, that's my rise. How much I go over by, that's my run. So my slope when I do rise over run would be 2 over 3 here. I want to take a linear equation that's been written in standard form, and we're going to put it into slope-intercept form. A couple things I want you to notice about slope-intercept form. Are x and y still on the same side? In slope-intercept form, are x and y on the same side? No. Where is y? Which side is y on? It's on the left. Does it have a coefficient in front of it? No. Y is all by itself with no other numbers or symbols at all. Right after the equal sign is where I see x with its coefficient. The slope is allowed to be a fraction here. The piece that does not have a variable with it at all is my y-intercept, and I put that at the very end. Let's go look at example 2, and we're going to put this guy into slope-intercept form. What does slope-intercept form look like again? Y equals mx plus b. That is slope-intercept form. So this is my map, this is my guide. When my equation has this form to it, then I know I'm done. We need to isolate or get y alone. So I'm going to go backwards through the order of operations to do that. When I go backwards through the order of operations, as I'm getting a piece alone, which operations do I have to start off with? Addition and subtraction. Which piece do we want to get alone here? If I'm aiming for slope-intercept form, which piece do I want to get alone? The y. So this, since I want to get it alone, has to stay put. I'm going to need to get rid of the 12x, and I'm going to need to get rid of the negative 4. What is connecting the negative 4 to the y? What operation? Multiplication. So I can't undo that yet, because I have to start with addition or subtraction. Is there a way to get rid of this 12x using addition or subtraction? Yeah. What would I do here if I wanted to make that cancel? Subtract 12x from both sides. All right. So what do I have on the left side? Negative 4y equals, I'm using this right here as my map, as my guide. I've got two pieces here. Which one should come right after the equal sign? I have this number and I have this number. I can't combine them because they don't both have x's.
Isn't it 12x?
Negative 12x. Nice catch. Negative 12x. After that, I'm going to put the 24. Is that 24 positive or negative? Positive. So when I write this down, I need to have a plus sign in front of my 24. So far, so good? Is this slope-intercept form? Not yet. What else do I need?
I'll get rid of the negative 4.
Get rid of the negative 4. How do I get rid of the negative 4? Divide. If I do it to one side, I do it to the other side. What do I do it to on the other side? Everything. We distribute with division just like we distribute with multiplication. So I have y equals what? 3x. Negative 12 divided by negative 4 gives me 3.
And negative 6.
And yep, negative 6 minus 6. Is this slope-intercept form? What is my slope? 3. The x part is not my slope. Just the 3 is my slope. Because remember, it's mx. So if I want just m, I want just the number. What's my y-intercept? Negative 6 is b. Nice work. Let's go look at a story problem. Example number 3. Again, we want to put this into slope-intercept form. So what form am I trying to get it into? What should it look like? Y equals mx plus b. Here's my equation right now. 3,246x minus 2y equals negative 152,722. This equation right here can be used to estimate the shoe sales in Europe from 2010 to 2015. I don't know who it is that is most interested in that information, but somebody wanted to use this information to predict shoe sales in later years. What does X mean here? Yes, X is the number of years after 2010. So they're using 2010 as year 0. That's when they're starting. So year 5 would be 20 what? Close. Year 5 would be 2015. Year 10 would be what? 2020. I'm just going to take year whatever and I'm going to add it to 2010. What does Y mean here? What does Y mean? The revenue in millions of dollars. Is that a million? No, we're going to have to take the answer that we find and we're going to have to change it into millions. So we might need to add some zeros on here. I want to get it into slope-intercept form first. That means I need to get y all alone. What would my first step be to get y alone here? Subtract. What am I subtracting? The 3246x. I'm going to subtract it from both sides. What do I have on the left side of the equation now? Negative 2 y. There we go. Right after I write down the equal sign, I've got two things over here. Can these two things combine? Why or why not? Yeah, one has an x, one doesn't. Can't combine them. So which of those two pieces do I write first? The one with the x goes first. So negative 3246x. What comes after that? What comes after that negative 3246? Yes. Negative 152,722. Do I have it in slope-intercept form yet? Yes, no, maybe so? Nope. What do I need to do to get it into slope-intercept form? Divide both sides by negative 2. We divide everybody over here by negative 2. So I get y equals what? Will this be a positive or a negative here? Guys, we got a problem to go after this one. Please stay focused so we can finish up. What do I get when I divide that first term by negative 2? Switch around. So there's a couple things that I still need you guys to look at a little bit. On number 14, or sorry, number 11, you didn't explain your no there. 14. C is not one of the correct choices, but there are 2 more correct choices. And then we'll talk about this, and then I can let you retake. Okay? What do I get? Negative 3246x divided by negative 2. I want to know what I get when I divide these two. Negative 3246x divided by negative 2. What do we get? 1,623x. Why is it not negative 1623?
Because negative divided by negative is positive.
Negative divided by negative gives me a positive. What do I get over here when I divide these two?
76, 361.
Right, you said 76 and then
361.
361.
Yeah.
All right. Why is that one not negative?
Okay.
Yep, I had a negative divided by a negative, so I got a positive there. What is our slope? 1623. What is our y-intercept? 76, 361. So what do those mean? What did we just find by putting this into slope-intercept form? What do we care? What questions can we answer now?
Represents the sales.
1623 represents that the sales increased by how much? My sales increased by how much?
16.
Yep. 1623. How are they measuring money in this? In just dollars? In millions of dollars. So this is 600 or $1,623 million each year. What does that 76,361 represent? That in year 0, which was 2010, what were the sales? What were the sales in year 0 in 2010? 76. 361 million. 76, 361 million.
How would that be a million? Wouldn't that be like a billion? 1,623.
Yeah. If you write it like that, we would say million, so that I know I have to put 6 zeros after it. But that would make it over a billion. You're absolutely correct. Same thing down here. If it was still just in this space with 6 zeros after it, it would be a million. When I write it like this, I still put million at the end to know that 6 zeros need to go after it. But that would be $76 billion. You're absolutely correct. All right. One more problem that I want to look at with you guys, and this one has a really important feature, so it is very important that we pay attention and we stay focused through this last problem. We've got a story problem, and they don't give me an equation. We're going to use the information that they give us, and we are going to come up with the equation. What 2 key pieces of information do I need if I'm going to write an equation in slope-intercept form? What will I need?
Slope and the y.
Yep, I will need the slope, and I will need the y-intercept. Slope tells me rise over run. Y-intercept tells me the initial or the starting amount. Before I can find the slope or the y-intercept, I need to define my variables. What is this whole problem talking to me about? Smartphones. What are the things that they describe in the problem? They're describing a relationship between smartphones and what? We have smartphone users. That's one piece of information they tell me about. Worldwide. What else, though? Because that's still just telling me one piece of information. We have 131 billion smartphone users, 2.38 billion smartphone users. Why are there two different numbers for users there? Why didn't they just tell me that number once? The year. That's our other variable. In 2010, there was 1.31 billion smartphone users. What year was it when it had gone up to 2.38? 2017. All right, let's define our variables. We have one variable that is going to be the number of years. Do we want to do the number of years since the beginning of time? Were there smartphones around 100 years ago? So it doesn't really make any sense as I'm trying to think about this to let 2010 and 2014 be my years. We're going to let X be the number of years after 2013. So that means that the year 2013 is year 0. Guys, put the phones away. Put them away and leave them put away. 2013 is year 0. 2017 is how many years later? Let's count. We're starting in 2013, and then we'd go to 2014, 2015, 2016, 2017. So 4 years later. So 2017 is year 4. It's important that I know this because we're going to come in here and find our slope. I'm running out of colors here, though. Y is the number of smartphone users measured in billions. What is slope again? Rise over run. When I think of an ordered pair, it tells me an X part and a Y part. Which axis goes left and right? The X axis. Which axis goes up and down? Y. So if I'm talking about rise, do I care about the X's or the Y's? If I'm talking about the rise, do I care about the X's or the Y's? Put the phones away. I care about my Y's. Rise is going to be the change in my Y values. That little triangle means change in. What's changing as I talk about the run? Is this the Y's changing if I'm going back and forth? What's changing? X's. Rise is a change in my Y values. Run is a change in my X values. I have a formula that I can use to help me figure out the slope. Y2 minus Y1, that'll tell me the difference or the change in my Y's, divided by X2 minus X1. That'll tell me how much my X's have changed by. I need to use ordered pairs to help me figure this out. When I use my ordered pairs, these two numbers have to come from the same ordered pair. In my fraction, the first number, top and bottom, has to come from the same ordered pair. The second value, what I'm subtracting, has to come from the same ordered pair, top and bottom. That's the only way I will accurately be able to describe how much the Y's have changed compared to how much the X's have changed. What information did they give us to work with here? What are our variables? What are our x and y meaning here? What did we say x means again? The years. What does y mean? Yep, we've got number of smartphone users. So I'm going to write two ordered pairs here. When are we starting? What year did we say we're going to start counting from? 2013, and that's year 0. So the x part of my ordered pair, this is the year. How many smartphone users were there in year 0 in 2013? 1.31 billion. It is a lot. If I'm going to talk about these things changing, I need another ordered pair so that I can compare these parts. What was the other year that we had to work with? 2017, which was how many years later? 4 years later. So the year is now 4 years later. How many users were there 4 years later? 2.38 billion. If you're subtracting two numbers, would you rather have a bigger number minus a smaller number, like 5 minus 3? Or do you want to do a smaller one minus a bigger one, like 2 minus 7? Which sounds easier to do? Do you want to do a bigger one minus a smaller one, like 5 minus 2? Or do you want to do a smaller one minus a bigger one, like 2 minus 7? Bigger minus smaller. So this first number here, I'm going to pick my bigger y value here. Which one of those y values was bigger? 2.38. We're going to come in here and find our slope. So 2.38. Right underneath this, I need the x part of that ordered pair. What's the x part of this ordered pair right here where we got that first number from? 4. Notice both of these numbers came from the same ordered pair. I have to do the y on top, but they both came from the same ordered pair. Yes?
How do you know it was year 0?
They told us right up here, let x be the number of years after 2013. So if I go after 2013, that'd be 2014, so that would be year 1. 2015 would be year 2. Anytime they say after this point, this year would be year 0. What do I need to subtract over here, top and bottom? Where do I get those numbers from? What are we subtracting to finish finding our slope here? What do I want to subtract from 2.38? 1.31. This is the y part of my other ordered pair. What would have to go on bottom with that? 0. These two numbers have to come from the same ordered pair. Y is on top, x is on bottom. Grab your calculators for me, and I want you to actually divide those. Subtract first. Yep. Subtract the top first. Tell me what we get when we just subtract the top. 1.07 over, what do I get when I subtract these two? 4. Divide these two on your calculator. So 0.2, tell me what your calculator says. 0.2675. If that third number is a 5 or bigger, we're going to round up. So 0.27. .27. So the number of smartphone users worldwide increased. How did I know it was an increase and not a decrease? How did I know this was an increase and not a decrease? From looking at just the slope, I can tell whether this is an increase or a decrease. How did I know based on the slope that this had to be an increase? What kind of number did we find when we found our slope? Is it a positive or a negative slope? Positive slope. If it is a positive slope,
Where's the slope at again?
that's what we just found. That was that 0.27. That's what we just found. That's our rise over run. If we have a positive slope, then it is increasing. What do you think it means then if I have a negative slope? It's decreasing. All right, so my slope is 0.27. How do I find B? How do I find B? What does B mean again? Y-intercept. Tell me what an ordered pair for a y-intercept always looks like.
The number and then zeros.
Close.
Zero and then a number.
0 and then a number for a y-intercept.
Oh, Y-intercept. I thought you said X.
Nope, y-intercept.
I seen X, but I thought she said X. Why did you see X? Right there.
Yep.
Thank you.
X is 0.
Thank you for underlining.
Do we have an ordered pair where the x part of the ordered pair was 0?
And the X, no.
Look here. Did we have an ordered pair where the x part of the ordered pair was 0?
Yeah.
Yes. What's the y part?
1.31.
1.31. We had 0, 1.31. So what's my y-intercept? 1.31. Coming from right here. So how do I write this equation then? I want to write it in slope-intercept form. Y equals mx plus b. Y equals 0.27 plus 1.31. There's my equation. There's still one more thing I want to do with this, and then we're done for today. Now that we have this equation, I want to use it to make a prediction. Is it 2025 yet? No. So I'm going to make a prediction. Year 0 was what year again? Yep. Year 0 was 2013. How many years into the future then is 2025? How much farther ahead in time? 12 years. 2025 minus 2013, which was year 0. And we get 12 years. That's what they told me right here also. Which variable means years, x or y? Let's go back and look. Number of years is our x variable. So I can take 12 and put it in the place of what in my equation? I can put it in for x. So I'm going to put 12 in the place of x. Grab your calculators. I want you to multiply 0.27 by 12 and then add 1.31 to it. 4.55. What does y mean again? What about the users? Is it just 4.55 users? Billion users. 4.55 billion users in 2025 is our prediction. If this pattern continues and they keep adding or increasing by 0.27 billion users a year, that's how many there will be in 2025. You guys have a homework assignment that's due tonight from the previous stuff, what we finished up talking about yesterday with absolute value. After that, your next assignment will be due on Wednesday. I don't see you guys on Monday. Why not? Labor Day. So no school on Monday. I'll see you again on Tuesday where we'll finish talking about linear equations. And this is the homework that will be due the next day.